Traditional infrastructure monitoring was built around stable, long-lived assets. A server has a fixed IP, a fixed name, a fixed set of services. Kubernetes breaks all three. Pods come and go in seconds. Names rotate with deployments. IP addresses change on restart. The monitoring infrastructure that worked for bare metal and VMs needs fundamental rethinking for a container platform. In Kubernetes, the meaningful unit of identity isn't the pod, it's the deployment. Pods are ephemeral. Deployments are persistent. A pod with a failed health check will be terminated and replaced within seconds, often before a traditional monitor has even completed its first check. The monitoring layer must follow the deployment, not the instance, tracking aggregate health across however many replicas are currently running, not individual pod lifetimes. Kubernetes observability operates at three distinct levels. At the cluster level, control plane health, etcd latency, API server request rates, scheduler queue depth. These metrics indicate whether the orchestrator itself is healthy, which affects every workload in the cluster. At the node level, individual machine health, CPU pressure, memory pressure, disk availability, and the kubelay that manages pods on that node. At the workload level, deployment replica counts, pod restart rates, horizontal pod autoscaler decisions, and container resource utilization relative to configured limits. Two ingestion paths are common. Push from the cluster using the OpenTelemetry operator or Prometheus remote write, and pull from the platform using the kubestate metrics plus node exporter plus kedvisor trio. Pull model ingestion from the platform side avoids depending on in-cluster components for data delivery, which matters when the control plane itself is degraded and you most need visibility. The namespace is Kubernetes' primary isolation boundary and a natural unit for monitoring. Treating a namespace as a first-class asset means it gets its own health view. Aggregate pod health, resource consumption, error rates, and active alerts rolled up to the namespace level without requiring per-pod queries. For platform teams managing multiple application teams, or MSPs running multi-tenant Kubernetes, namespace-level observability is what makes the platform operationally manageable. Kubernetes-native observability and synthetic monitoring are complementary, not redundant. Synthetic checks targeting your ingress or service endpoints measure what external users experience. K8s metrics tell you what the cluster is doing internally. When both live in the same platform, a synthetic latency alert can be immediately correlated with pod restart activity, HPA scaling events, or node pressure conditions, the internal cause of the external symptom. The evaluation question: when K8s data arrives in the platform, does it organize into a navigable hierarchy, cluster, namespace, deployment, pod, or does it arrive as a flat metric stream that requires manual labeling to make sense of? The difference is the difference between a K8s-aware platform and a general-purpose metrics store that happens to receive K8s data.